factoring and solving equations. And so one warning up front on this section is to make sure that you get the first couple steps correct. Be very careful with negatives. Put as much as you can down on paper, because the more you put on paper, the less mistakes, the fewer mistakes you're going to make as you go through. So you have to think about it anyway. Get it on paper, look at it, and generally you make fewer mistakes when you do that. I want to do 3 problems today involving solving for an unknown. These are all questions in the back homework set of the section. We're still on 6.1, and in this chapter you're going to have 3 sections on solving equations like this, but they're going to get more and more complicated. And then the last section is going to be on parametric equations, and that's going to be a wrap on this chapter 6. Keep in mind the test for chapter 6 is going to be about half is going to be take home, where you can use the resources that you want. Just make sure that everything is in very good form, and that will test the harder problems. And then there will be a second half, which will be in class during finals week. And then that chapter 6, both scores will compose of your overall chapter 6 test. So let's go to number 26, where it says you have a square in it, and it's a trinomial. And so the first thing you want to do is factor that problem. Now, if you want to, it may make more sense to actually write it like that, so you can see how to factor out your y's. If that confuses you, you can always go from the beginning. Going from the beginning is simpler. You just have to keep things in order. Notice you're dealing with radians up front, and I see students that drop the 0. Make sure it's an equation all the way through. You want to make good steps on these. They are going to get longer. You want to have a good form, a good system in order to solve these problems. So let's go here and put down the parentheses and treat these terms like they are cosine x. And the only option you have is to put in 2 cosine x and cosine x into the first term, because when you multiply them, you get what's above. And then the second one is you have this negative. The negative can be a plus minus or minus plus. So you're kind of thinking now, but this 1 means this has to be a 1 and that has to be a 1. So if you were to break this down, it's not too hard at this point to see that in order to get a positive middle term, the plus sign must go here, because you're going to have the plus 2 cosine x and a minus 1 cosine x. And always double check that middle term. Minus cosine x plus 2 cosine x gives you a positive cosine x. Doesn't take long. It avoids making mistakes all the way through. If you don't factor this correctly, everything that follows is going to be off. Double check. I can guarantee you students will be making mistakes on factoring during the test, and everything that follows is going to be off because of it. So double check that. All right, so this can equal 0, or that could equal 0. It's called the zero product property. You always want 0 to be on the right-hand side. So I'm just going to write that down. 2 cosine x minus 1 equals 0, and cosine x plus 1 equals 0. Solve each of those for cosine x. Again, be very careful not to get careless when you go ahead and solve those. And then you have 2 different equations that you're working with to get your answers. So at this point, you're going to have again, a positive cosine, which means by referring to Santa Claus, it's going to be here and it's going to be there. You want to draw something to give you a visual on where those angles are. And so this is cosine is positive in the first quadrant. You need to know those reference angles, and then you can get your angles. So reference angle, then you can look at the table or unit circle, depending upon which way you choose. Cosine of what gives you 1/2? That's going to be, going back up to here in radians, is going to be pi over 3. I remember that because I remember the sine of pi over 6 is 1/2. That's got to be the other one. So you know the reference angle is pi over 3. I can figure those out at the end. Now I'm going to jump to this one. Cosine x equals -1. This -1, if it's 0, -1, or +1, you do not set up this. You go and you actually draw the cosine in. Drawing the cosine in will give you your answers at the points that you're looking at. So for example, on this one, you're at -1. So this is 0 to 2 pi. You're going to see that that's halfway, so that's actually going to be at pi. Again, -1 is your focus. So I'm now ready to write down all my answers because I did all the hard work. Off to the side, my x is going to equal pi over 3. I see it's also going to equal pi. And then on this one, it's going to be all the way around here with pi over 3 left. And so just as a reminder, if it goes all the way around, you're really talking about 6 pi over 3. So I'm taking pi over 3 away from 6 pi over 3, and I'm left with 5 pi over 3. Yeah, it's nice because all the angles are in order from small to large. But it doesn't have to. It's just easier to read. A lot of work, a lot of potential of mistake. Take your time, double check things as you go throughout the problems. Question number 32 says 2 sine squared theta minus 7 sine theta equals -3, and we're dealing with degrees from 0 to 360. In this problem, you're going to see that it's not equal to 0, it's equal to -3. So you have to recognize up front that you have to change that. In order to factor or do anything, it's got to be equal to 0. So on this one, we're going to say 2 sine squared theta minus 7 sine theta plus 3 equals 0. I'm looking to see, can I take anything out of these three terms? No, I can't. Now I go ahead and factor it. Trying to keep things relatively lined up. 2 sine theta has to go into those first spaces. I also know that because this is plus and this is minus, it has to be a minus and a minus. I'm certain that is true. The only thing now is a choice on where the 3 goes, the 3 and the 1. So I'm looking at the middle term. It's a high middle term based on these. The 3 has to go here to get this to be a higher number. Again, double checking. Minus 1 sine theta, minus 6 sine theta, negative 7 sine theta. It works. So I did that correctly. So now I'm going to say, okay, this is true, and this is true. Now, as you're going through and solving these, one thing I want to notice is that the sine theta equals 3. That looks a little bit weird in terms of what I've dealt with before. And I want to remember that when you graph the sine graph, you're going to go from -1 to 1. In other words, the range of the sine graph is -1 to 1. The sine theta can never equal 3 because it's out of the range of that graph. So I'm just going to take this one and cross it off because your theta does not exist to yield the sine theta of 3. Then I only have to deal with this one. Again, we're looking at drawing it to make sense here. It's positive here. It's positive here because of Santa Claus. Those are my reference angles. Dealing with degrees, reference angle is equal to 30 degrees. That's the one that I always remember when I'm thinking about that table in my head, and I can get everything else based off of that. All right, so now I can go over here, write down my answers. Theta is equal to 30 degrees, and it's also equal to 150 degrees. Because it's 180 minus the 30. So when I draw this, I'm now just drawing it in and showing the reference angles, and that's all I pretty much need to do at this point. Hopefully you've had enough practice on this type of stuff that comes second nature. The last problem I'd like to do is one that looks a little bit different, and students can have problems with this one, not for really a good reason. It's not that hard of a problem. It's just a different way of thinking about it. The question is cosine 5a plus 15 equals -1 over square root of 2. And the directions, again, find all degree solutions. That's where I have that K business. I have to put that in my answer. To do this, I want to think about this as like a big theta. It's kind of like substituting in a theta for that, and then that's how I want to think about it. So the question really is, the cosine of theta is equal to a -1 over radical 2. What does your theta have to be? Well, that's the same. You do the same approach. You draw it, and through Santa Claus, you're going to know the cosine is negative here, and the cosine is negative here. These are your reference angles. And so I can say that my theta is going to be this angle right here, and my theta is going to be that angle right there. And so now I want to identify those. Well, the reference angle, cosine theta equals 1 over radical 2, because it's positive. That's just going to be 45 degrees, again, by the table or unit circle. And now I can get my angles. Now, watch what I do at this point. I'm going to say that instead of theta being equal to the angle, I'm going to say it's going to be 5a plus 15 is equal to the angle. So I just write that down. 5a plus 15 is equal to the first angle, which is going to be 180 minus 45, which is 135, plus 360k. Look what I'm doing. I'm putting that in on the very first step because it says all degree solutions. It's this one, and then it's every time it wraps around to keep hitting that 360. I do not add that in at the end. I add it in right at the beginning. The other one, so I can do the same thing, is 5a plus 15 is equal to 180 plus 45, which is 225 plus 360k. After you write those down, all it is solving for your A. That's it. So you're focusing on those two letters and solving it and combining like terms. So that should be relatively easy. You subtract off 15 on both sides. And if I can do that the same thing down here. Then it's a matter of dividing by 5 on both sides. Now when you divide by 5, you've got to do it all the way through on both sides. So this becomes A equals 24 plus 72K, 24 degrees plus 72 degrees times K. Again, K represents all integer values, 0 plus or minus 1 plus or minus 2 plus or minus 3. And down here, it's going to be A is equal to 42 plus 72K. And I want to make, through all of this work, you want to make your answers very obvious. So you want to put big circles around these. This is not the tough problems. They're going to get longer and more confusing. So we want to have a good base on how to do these so that when we get to the longer ones, it becomes more second nature. Okay, we'll continue with 6.2 tomorrow on solving harder equations.